Now my dear students, we can see this question number 34. Aluminum chloride forms a dimer because here my dear students, what is the structure of aluminum? That is, the structure of aluminum is AlCl3, but we can see that aluminum is form a dimer Al2Cl6. Why this aluminum form a dimer? Here we can see my dear students, this can have higher coordination number because in aluminum d orbital, and that d orbital is a back-end d orbital. Back-end d orbital is present in aluminum. Here we can see that back-end d orbitals are present in aluminum. So my dear students, this aluminum form the AlCl3, Al2L form because back-end d orbital are present. So here this aluminum is formed in the form of Al2Cl6, and in this formation aluminum get the higher coordination number because this is the Al, Cl, Cl and this Cl. Here lone pair of electrons are present in chlorine. Here second molecule of this Cl, Cl and Cl. Here in this lone pair of electrons are present in this chlorine. Now we can see here in aluminum these electrons, lone pair of electrons of chlorine give this aluminum back-end orbital of this aluminum because this aluminum is a 13 group elements. So 2 electrons are less, and this electron pair of this chlorine give from the coordinate bond to this aluminum. So my dear students, this Al2Cl6 is formed, and this is the structure of Al2Cl6, and due to this we can see here aluminum form a dimer. It's a dimer. So aluminum is present in the form of dimer. Now we can see here my dear students, question number 34, answer is B. This question is also asked in 1995 NEET exam. Now we can see here question number 35, which one of the following element is unable to form MF6 minus 3 ion. Here my dear students, we can see here those element in which d orbital is absent. Concept, those elements in which d orbital is absent, cannot form higher coordination number. And you can see here this is the higher coordination number. So this boron cannot form this higher coordination number. So my dear students, you can see here question number 35, correct answer is B. This question is also as in NEET 2018. Gallium is formed because d orbital is present. Here d is present. Aluminum is formed, d is present. You can see the LF6, K3LF6. Indium is formed because d is present. So here you can see the question number 35, you can see the C option is the correct answer. Now we can go to the question number 36. The tendency of BF3, BCl3 and BBr3 to behave as Lewis acid decreases in the sequence. Here my dear students, you can see here Lewis acid behavior. What is the Lewis acid? What is the concept? Those elements accept electron pair behavior is Lewis acid. This is our first point. Number second, when we go to the here boron in all examples of boron, but you can see here change the halogens. So, my dear students, if you see these halogens, fluorine, chlorine, bromine, you see that this fluorine smaller in size, chlorine bigger and bromine is bigger in size. Here, my dear students, BF3 is small in size, but BF3 is not accept the lone pair of electrons. Behavior of this Lewis acid is compared to bromine and chlorine is less. Why? You can see here when size is bigger, behavior of Lewis acid is greater. It means, my dear students, this fluorine atom and boron atom is smaller in size and lone pair of electrons present in fluorine. So, those lone pair of electrons go to the boron. Here when fluorine and boron are present and both are in small in size. And here you can see the lone pair of electrons are present on this fluorine atom. My dear students, because these are smaller in size, here empty orbital is present in boron. So, these lone pair electrons which are present in orbital are overlap with each other easily, because here bond length is very low, very small with compared to boron and Br and Br. Br is larger in size, and my dear students, when Br is larger in size with compared to fluorine, the electron pair are also present in boron, lone pair electrons also present in this bromine. But this pair of electrons which are present in the orbitals are not overlap the empty orbitals of boron, because size is bigger. So, these electrons, these orbitals are not overlap with each other. So, my dear students, this boron atom is empty and accept the electrons. So, BBr3 have greater acidic character, greater Lewis acidic character than BF3. This is the reason and this is the concept. So, concept and reason, you can get this answer. So, my dear students, your answer is question number 36, your answer is B. Now, we can see the question number 37. Boron compounds behave as Lewis acids because of their simply electron deficient nature. 996, question number 37, answer is B. We can already discuss this in 36 question, already discussed. Now, we can see here question number 38. Boric acid is an acid because its molecule. My dear students, what is the boric acid? Boric acid is the S3BO3 molecules. What is the structure? Here you can see the structure of boric acid, OH, OH and OH. And here you can see the in boron 2 electrons are less, because oxygen and boron form the electron pair covalent bond. So, 2 electrons are less in boric acid. But this boric acid accept OH minus ions. Why? Because boron bond the lone pair electrons or an ion. So, this BOH attach on this boron and form the BOH 1, 2, 3, 4, 4 bonds, means it is converted to BOH minus, and structure is boron OH, here OH given this coordinate bond, here OH and OH. So, my dear students, here you can see this is the boric acid is a acid, but it accept this OH minus ions, and when this accept OH minus ions from the water, accept this OH minus ions, because in water OH and H plus ions are present. Accept this OH minus ions and remove this H plus ions. This H plus ions go to in the solution. So, this boric acid, behavior of boric acid is same as a acidic behavior, but it cannot give H plus ions. H plus ions give by the water molecule. So, boric acid is an acid, my dear students, because its molecules accept OH minus ions from water and releasing proton. So, this is the reaction and concept. Now, we can go to the question number 39. Which of the following structure is similar to graphite? My dear students, graphite structure is a layer-like. Layer-like structure is present in graphite, number 1. Number 2, sp2 hybridization present in graphite. And in this type, number 3, one lone pair of electrons, one electron is unpaired present in graphite. Due to this electron, graphite is a conducting in nature. So, this graphite used as a electrodes. Now, we can see here structure of graphite is same as a, my dear students, it is called Bn, boron nitride. Boron nitride and graphite have same structure, it is a layer-like structure. So, you can go to the answer, that is C. Question number 39, you can go to the answer C, question number 39. Now, we can see the question number 40. The type of hybridization of boron in diboron is. My dear students, we can see here concept and reaction. Here we can see the diborane. Diborane is the B2S6 is called diborane, my dear students. Here I give you already structure of diborane, and this structure of diborane we can see here further, and here this is the lone pair of electrons which are sharing with this. So, it is called 3-center 2-electron bond, because my dear students, here you can see the 1, 2 and 3 center present, and 2-electron bond is present in a 3 center. So, my dear students, you can see here this is called 3-center. Here you can see here 1 center, 2 center and 3 center. So, it is called 3-center, 2-electron. Here 1 electron here and 2nd electron here. So, it is called 3-center 2-electron bond. My dear students, it is called 3-center 2-electron bond. Now, my dear students, we can see here BS3 molecule. This BS3 molecules, when diborane is formed, then this BS3 molecule is a sp3 hybridized. So, you can go to the answer A, question number 40. Now, we can see here question number 41. Which of the following statements about S3BO3 is not correct? Here we can see it has a layer-like structure in which planar BO3 units are joined by hydrogen bonds. It does not act as a proton donor, but act as a Lewis acid by accepting hydroxyl ion. This is correct, this is correct. It is a strong tribasic acid. My dear students, this is not correct. It is not a tribasic acid, strong tribasic acid. It is a monobasic acid because H plus ions is given by the water molecule. It is not a proton donor, but act as a Lewis acid by accepting OH minus ions. So, my dear students, question number 41, you can go to the answer C. Now, we can see the question number 42. Which of the following is incorrect statement? This question is asked in NEET 2019. Here, my dear students, we can see here incorrect statement. Carbon, silicon, germanium, tin and lead. This is the 14th group elements. Here you can see the in 14th group elements, electronic configuration is NH2, NP2. So, these elements are formed MX4 type bonds and MX2 type bond. Here, when you see the lead, heavy metal, it forms the MX2 type bond more stable due to inert pair effect. So, my dear students, here germanium is also a with lead. So, Mx2 means +2 oxidation state is more stable than +4. So, you can see that stability of +4 oxidation state decreases. When, my dear students, you can see here stability of +4 oxidation state decreases, it means +2 oxidation state stability increases. It means stability of +2 oxidation state increases. So, here you can see that GX4 germanium is more stable than GX2, because here +4 oxidation state stability decreases. Here in this germanium +4 oxidation state stability is less, and here this is greater. GEX4 is more stable, here more, and +2 is less. But in PB case, PBX2 is more stable than PBX4. But in germanium, it is not correct. Here GX2 is less stable, GX4 is more stable. So, statement is correct. Now, we can see here SiCl4 is easily hydrolyzed. Yes, SiCl4 reacts with water to form SiOH4 plus 4HCl. So, my dear friends, it is easily hydrolyzed. PbF4 is a covalent nature, because here oxidation state PbF4 is a covalent in nature. Here, my dear students, when we can go to the question number 42, this is a incorrect statement. Why? Because PbF4 here +4 oxidation state is covalent in nature, it is a ionic in nature, because fluorine is a small in size, SN4 is a ionic nature, correct statement. So, you can see here question number 42, answer is B, and this question is asked in NEET 2019 exams. Now, we can see here question number 43, which of the following species is not stable? This question is also asked in, my dear students, NEET 2019. Here we can see that question number 43 is not stable, and that is the answer is A. Why, my dear students? What is the reason? It is not stable. Reason is that carbon silicon, it is a second element, second period elements. So, my dear students, coordination number is not more than 4, and here SiCl6 coordination number is present in 6. So, silicon is not formed this 6 coordinate bond with chlorine, because size of chlorine is greater than size of fluorine. So, my dear students, this fluoride ions always get the highest oxidation state, or fluoride ion always get the highest coordination number, So, my dear students, answer is A. Question number 43, answer is A. Now, you can go to the question number 44. It is because of ability of NH2 electrons of the valence shell to participate in bonding that Sn+2 is oxidizing while Pb4+ is reducing. My dear students, you can see the concept. First of all, Sn+2 is converted to SnCl4 plus 4. Here SnCl2 is converted to SnCl4. Here PbCl4 plus 4 converted to PbCl2 plus 2. Here PbCl2 is also converted into PbCl4, but you can see that Pb plus 2 oxidation state is more stable than Pb plus 4 oxidation state. due to inert pair effect. Now we can see the question. Here we can see the question, bonding by this NH2 electrons, this carbon, silicon, germanium, tin and lead. Here electronic configuration is NH2 and P2. Here when this NH2 bonding is there, it is involved, means this element go to the higher oxidation state. So my dear students, in higher oxidation state, this Pb plus 4 is not go. Here bonding of Pb plus 4 is go to the Pb plus 2 and Sn plus 2 is reduced while Pb plus 4 is oxidized. So my dear students, here you can, question number 44, you can get the answer D. What is the oxidation? What is the reduction? You know very well. When this Sn plus 2 plus 4, it is called oxidation done, and when this is the oxidized, means it's act as a reducing agent. Now when Pb plus 4, when we get the Pb plus 4, it is converted to Pb plus 2, means it is the oxidation number, oxidation state is reduced, it's act as a oxidizing agent. So my dear students, this Pb plus 4 get oxidizing, it's act as oxidizing agent, and Sn plus 4 is act as a reducing agent. So in this concept you can go the answer D. Sn plus 2 is reducing while Pb plus 4 is oxidizing. Now we can go to the question number 45. Which of the following oxidation states are the most characteristics for lead and tin? Here my dear students, concept is that carbon, silicon, germanium, tin, lead. Here my dear students, NH2 and P2 is the electronic configuration, and here stable oxidation state is plus 2 due to inert pair effect. This pair of electrons is not taking part in the bonding. So here you can see the in lead plus 2 oxidation state is more stable than plus 4. But when you can see the tin, here tin you can see the plus 4 oxidation state is stable than plus 2, because inert pair effect is not applied here due to inert pair effect. So my dear students, question number 45, you can go the answer A. Here lead get the plus 2 and tin get the plus 4 oxidation states, and these are the most common and stable oxidation state, and due to this is done due to the inert pair effect. Now my dear students, we can see here S block hydrogen and P block 13 and 14, we can cover all the questions which are asked in last 40 years. And you can see the oxidation states for P block groups, inert pair effect for P block groups are present. So my dear students, you can ask all the questions which are coming in your exam. Thank you.